we will discuss about the third application of dimensional analysis. So far in the last video we discussed the applications of dimensional analysis. The two applications are, one is to derive a physical relation involving different physical quantity. Next application what we have derived is that by using that dimensional analysis we can check whether a relation is dimensionally correct or not. Next, the third application of this dimensional analysis is, as I have already given, the third one is to convert a physical quantity from one system of units to another. Here what it means is that to convert a physical quantity from one system of units. So already we have discussed about the systems of unit, CGS, FPS, MKS, SI systems of unit. If I know the value of a physical quantity like force, acceleration, gravitational constant, Planck's constant, whatever may be the physical quantities that comes in our physics. So if I know the value of a physical quantity in one system of unit, suppose in CGS system of unit, then I can convert it into another system of unit, maybe in SI or FPS. We can convert the value of the physical quantity from the one system to another system. That we will discuss here. And before we discuss this one, let us understand the thing. We will derive a formula first. By using that formula we can convert the physical quantity from one system of units to another. What that is the magnitude of a physical quantity. Remember this one, the magnitude of a physical quantity, magnitude of a physical quantity, the magnitude of a physical quantity remains the same, remains the same. The magnitude of the physical quantity remains the same whatever may be the system of units, whatever may be the system of unit, whatever may be the system of unit, whatever may be the system of units. Is that clear? The magnitude of a physical quantity remains the same. What it means, the magnitude of a physical quantity remains the same means what? Let me make it clear that when we think about a physical quantity, the simple example, suppose I think about a physical quantity like your mass, and a mass of 1 kg, the magnitude of a physical quantity, this is the magnitude of a physical quantity which can be written as the numerical part and the unit part. And which physical quantity? The physical quantity is your mass. So mass is the physical quantity and its magnitude in 1 kg, this is in which system? MKS, or you can say SI, MKS or SI system. So it remains same whatever may be the system of unit. Means if the same mass of 1 kg, if I calculate in CGS system, then in CGS mass is measured in gram. CGS mass is measured in gram, means this 1 kg I can write this as 1000 gram. This is the what I have written here, the magnitude of mass of 1 kg, whatever may be the system of unit, maybe kg, maybe gram, or you can make it milligram or any value to any system of unit. You can convert that to any system of unit. This magnitude remains same. 1 kg is same as that of 1000 gram. That is the point. Okay. So now next part we will go for the formula. Clear? Is that clear to everybody? The magnitude of a physical quantity remains the same whatever may be the system of unit. With this concept, now we will find a relation. Okay. So now let me find a relation to convert one system to another. Okay. So if U1 and U2 are, if U1 and U2 are the units of measurement of a physical quantity Q. Q is a physical quantity. Q is a physical quantity. U1 and U2 are the units. U1 and U2, these are the units in different systems of units. Okay. Then for that, if it is in U1, in this system of unit U1, let the numerical value is N1, and U2 let the numerical value is N2. So N1 and N2 are the numerical values. Is that clear? So what I have considered here, U1 and U2 are the units of a measurement of a physical quantity Q. The physical quantity may be acceleration, velocity, may be gravitational constant, may be Planck's constant, whatever may be the physical quantity Q. And U1 are the systems of unit. It may be CGS, may be SKS, may be CGS, may be MKS, or it may be FPS. So these are the systems of unit. And in these two systems of unit, the corresponding numerical values are N1 and N2. Or N1 and N2. Corresponding values are N1 and N2. Is that clear? So now you can write what I have written there. The physical quantity, whatever may be the system of unit, the magnitude of the physical quantity remains same. So same means if in this system of unit I will write, the measurement can be written as numerical part with the unit part. So Q should be equal to N1 U1. This measurement should be N1 U1 like that. Mass is equal to 1 kg. 1 is the N1 and kg is U1. And that must be equal to N2 U2. That must be equal to N2 U2 means 1000 gram. In our example, that is 1000 gram. So N1 1 kg, 1 changes to 1000. It is kg changes to gram. This remains same. Is that clear? So this measurement from the first derivation part, we got this Q is equal to N1 U1, that equal to should be N2 U2. Okay. Now, when we find the unit part, when you get the unit part, here I have given a simple example for mass. Suppose I will go for force. So this force in MK system depends on mass, length, time, as you know its dimension. M1, L1, T minus 2. It depends on mass one time, L one times, and T minus 2 times. That already we know. But if in the same case, if U1 is the unit, suppose I will say the force unit is kg meter second minus 2. So this is kg meter second minus 2 is the unit of force in one system of unit, means it is nothing but it is the multiplication of 1 kg 1 meter into 1 second minus 2. This is nothing but your 1 kg 1 meter 1 second minus 2. It means it has involved a mass m and a length L and a time T. So here this mass I will take M1, L1, T1. Suppose I convert that to CGS, then this kg becomes gram, meter becomes centimeter, and second remains second. So in that case, this M1 now here changes to M2, L2, and S. Suppose I will take it T2, it is here T1, so both are same, but I will take this as T2. So my point is that let this is called, this M1 is called as the size. This M1 is called as the size, okay, of the fundamental unit. So now I will write the next part. Let this Understand this one. Next I will write this as let M1 L1 T1, let M1 L1 T1 be the M1 L1 T1 be the size of fundamental units, be the sizes of fundamental units, fundamental units of what? Fundamental units of mass, length and time, mass, length and time respectively, mass, length, time respectively, in one system, that is your U1, in the system of unit, in the system of unit U1. M1 L1 T be the size of the fundamental units, means if in this system is a MK system, then M1 must be 1 kg, L1 must be 1 meter and T1 must be 1 second if it is in a MKS. If it is in a CGS system, then M1 must be 1 gram, L1 must be 1 centimeter and T1 must be 1 second. That is the point. And similarly, okay, and next, and M2, L2 and T2 be the size of fundamental units, size of fundamental units of the same physical quantity, mass, length and time respectively in the which system? In the system of unit U2, right, in the system of unit U2. So I can write here, and M2 L2 L2 be the size of the fundamental units in the system of unit, in the system of unit U2. Clear? In the system of unit U2. Is that clear? Now, after knowing that in the two systems of unit U1 and U2, M1 and M2, M1, L1, T1 are the size. Then after that, if the dimension formula of the physical quantity Q, if the dimension formula of the physical quantity Q, in the dimension formula of the physical quantity Q be M to the power A, L to the power B, T to the power C. A, B, C may be 1, minus 1, minus 3, half, whatever may be the values. So let the physical quantity Q is equal to like this, be M to the power A, L to the power B, T to the power C. Then what I can write now? Then I can write this as, now you see here, now I can write in the system of unit U1 for the physical quantity Q, in the system of unit U1 for the physical quantity Q, U1 must be M1, the size, it is the what? Size of the fundamental M1, and what is this dimension? M power is A, so it is M1A, and L1 to the power B and T1 to the power C. Similarly, U2 should be M2 to the power A, L2 to the power B and T2 to the power C. This should be like this. Okay. Now, if both are same, now go to your relation this one. So if both are same, now you clear about this thing. Now let me erase this part. If this is the true, this is true, then I can write this as, now I can write, if this is true, then I can write this Q physical quantity is equal to, what is that physical quantity? Q is equal to N1 U1 is equal to N2 U2. So I can write this as N1 as it is, M1 to the power A, L1 to the power B, T1 to the power C like this is equal to N2 U2 is equal to M2 to the power A, L2 to the power B, T2 to the power C. Isn't it? I can write like this. So from here we can find this N2, the numerical value N2 should be equal to N1, M1, L1, M1 to the power A, L1 to the power B, T1 to the power C divided by M2 to the power A, L2 to the power B, T2 to the power C. So if you write it more clearly, then I will get the relation as N2 is equal to N1. Let me write M1 by M2 to the power A, L1 by L2 to the power B, and T1 by T2 to the power C. And this is my required formula. Let me keep in mind, this is the required formula. So from this we can say that from this N1, what is this N1 and N2? N1 and N2 are the numerical values of the physical quantity in the systems of unit. Okay, and N1 is the in which system where the size is mass size is M1, L1, T1, dimension of the physical quantity are A, B, C, and N2 is the numerical value in which system where the size of the mass M2, L2, T2, mass, length and time, these are the size. And remember this formula. By using this formula, this equation can be used to find the numerical value of the second or a new system of unit. This formula remember, and if I solve a problem, then you can get a clear idea what are the steps. Now you remember this one. Okay, take a photo of this one and you will remember this forever. When you are deriving that, I will put that directly. Okay, now see the question. Convert 1 joule into arc. Convert 1 joule into arc. This is a question. Clear? This is question where it is given that convert that 1 joule into arc. What we will do here? Now, how to find out? By using the third application of dimension analysis. Now you see here. When the question is given, first you should know this unit, joule and arc. These are the units of work or energy. Clear? These are the units of work and energy. And already you know that joule is in SI, or you can say that is in MKS, SI system, and arc is in CGS. And this SI and the CGS and the physical quantity is your work. Physical quantity is work or energy. Okay. Sometimes in the question is not given that convert 1 joule of energy into work. Then you can clear that it is energy or work. Okay. But it is given like that. Then you should know that the unit is of which physical quantity. Clear? Now go by step. Now we will go for the solution. Then you can get a clear. Okay. The derivation is not important. Remember the formula. Okay. Now let me do for the solution part. Let's go for the solution. Okay. Now first to find the dimensional formula of which physical quantity? Dimensional formula of work or energy, you can say also. No, work is M1 L2 T minus 2, isn't it? Work and energy is M1 L2 T minus T. So from here we can know that I am converting 1 joule of work or 1 joule of work or energy into arc. So on that, first you write this A is how much? 1. B is equal to how much? Power of L 2. C is how much? Power of T, that is minus 2. That you ABC, first you know that. Because you remember your formula, N2 is equal to N1 into M1 by M2 to the power A into L1 by L2 to the power B, T1 by T2 to the power C. Okay. Now you go for the size of the units in SI first, because we are changing from SI to CGS. So let me write first SI. Clear? these are the system of unit. Here mass M1 must be in this first system, mass M1, the size of the M1 should be in SI, it is 1 kg. L1 should be 1 meter, T1 should be 1 second. I am converting to which system? CGS or using CGS. In CGS, M2, CGS mass, gram, L2, centimeter, 1, T2, 1 second. Time dimension 1 second and 1 second. And what is the numerical value in this system given? This part 1. And here I will find out what this N2. I have to find out this N2. Now I got everything. Put the formula directly. Put the formula. N2 is equal to N1 M1 by M2 to the power A, L1 by L2 to the power B, T1 by T2 to the power C. Put that. Clear? So this is equal to N1 is 1. Let me 1. M1 1 kg by M2 1 gram to the power A is 1. Then L1 1 meter, 1 centimeter, L2 B is 2, T1 1 second, 1 second to the power C is minus 2. Clear? Now we will make that. I will cancel this one. I can convert kg to gram. I know that. Meter to centimeter or centimeter to meter. I know. And second is not problem. It can cancel. Okay. We can cancel this. So for that I can write this as 1. Okay. Correct me if I am wrong. I can write this as in this part. I can write. Let me make this kg to 1000 gram. Right? I know that by 1 gram. No change to the power 1. Then meter 100 centimeter divided by 1 centimeter to the power 2. 1 second, remain 1 second to the power minus 2. Clear? So now you see here 1 gram into 1 gram, this gram get cancelled. Clear? This centimeter get cancelled, second get cancelled. So what I will get here? 1 into 10 to the power 3. Gram cancel to the power 1 into 100 10 to the power 2 to the power 2. 100 means 10 to the 2 to the power 2. This is 1 to the power minus 2. Clear? Okay? Remember these steps. Then the next part is your. Now I will write the next part. The next part is N2 equal to. Now we got this. N2 is equal to 1 into 10 to the power 3 to the power 1, 10 to the 3, 10 to the power 2 to the power 2, 10 to the power 4, then 10 to the power 1 to the power minus 2, that is 1. So this N2 you can write this as 10 to the power 7. This N2 is equal to 10 to the power 7. So what I can write now? I will write that. I will have to convert 1 joule. So I can write 1 joule. 1 joule is equal to, what is my N2? 10 to the power 7. To convert which one? Org, because I have taken that for org, gram, centimeter, second, with powers 1, 2, minus 2 I have taken. So it automatically org. This is my answer. This is my answer. Clear? Now let me go for the second, another one. Okay? Now come to another one. The density of mercury. Density. Physical quantity is written. So no problem, you can find. The density of mercury is 13.6 gram per cm cube. In CGS system, everything is given in this question. It is very easy for you if it is this type of questions are. But don't expect always this type of questions will be asked. It may be some more or some little bit of modification may be in the question. So here it is given directly in a CGS system. Find its value in MK system. Now we do here. First, what I will do, right? Tell me what first I will take? Density, the physical quantity density. What is its dimension? From here also you can write. It involves gram means mass, m to the power a. Cm means L to the power b. Right? So Ma, A is what? 1 time L is minus 3. So this is the dimension. Means A is equal to what? Here A is equal to 1 and B is equal to minus 3. Generally the powers of M is taken as A and the powers of L is taken as a B. Okay? You can change also, accordingly you can use the convention. Okay? Now, after getting this one, now I will change in what? In CGS. Now go for CGS. CGS to MKS. I have to convert to MKS. So in CGS, let us take M1, 1 gram, L1, size of the units L1, T1, 1 second. And what is N1 given? In CGS, 13.6. No need to write unit. It is N1 means only the numerical part. Clear? No need to write. Then in MKS, I will convert that M2, 1 kg, L2, 1 meter, T2, 1 second, and N2 I have to calculate. Use the formula. Okay. Now I will use the formula here. What is the formula? N2 is equal to N1, M1 by M2 to the power A, L1 by L2 to the power B, T1 by T2 to the power C. So according to that, what is N1? 13.6. Then M1, 1 gram by 1 kg to the power A. A is what? 1. Then L1, 1 centimeter divided by 1 meter to the power B minus 3. Then there is no T factor. C is not G, C is 0. So no need to write this one. Only I will write this one. This part is 1. No C factor. So it is not required here. So I will write up to this much. No need to write this one because it involves only A and B. Clear? That is my point to write this thing. Okay. So this is equal to, now what I will do? This is equal to 13.6. Make this gram to kg or kg to gram. So I can make 1 gram by 1000 gram to the power 1. 1 centimeter by 100 centimeter to the power minus 3. Or you can convert this cm to meter also, no problem. So this gram can cancel. So 13.6. So I can 1 by 1000. I can write this as 10 to the power minus 3. 1 by 10 to the 3. When it goes up 10 to the minus 3 to the power 1. Then this will be 10 to the power minus 2 to the power minus 3. Clear? This will be the power of minus 3. Now, then I will go for the in SI system. Okay. So to solve this one, is that clear? I have taken everything the same, right? Density, mass by volume. Okay. So now I will take this as a now you solve this one. N2 is equal to 13.6 into 10 to the power minus 3 into 1, then 10 to the power, remember this multiplication, minus 2 minus 3, minus minus plus 3 into 2, 6. So this is equal to 13.6 into 10 to the power 3, that is my N2. So what I will write here? 13.6 given gram Cm minus 3 is equal to 13.6 into 10 to the power 3. What? In what system? Gram changes to, I have taken kg, power is what? 1, Cm, meter to the power minus 3. Kg, meter minus 3. Okay. Next. These are the simple types of examples you can find. Next I will go for a twist to this one. I don't know the system of unit. The system of unit, someone has given me a system of unit where mass is not 1 kg or 1 gram. Mass is 100 gram. M1 and L1 is 20 centimeter is a standard one. In that case also, we will use that. That's the twist one. Okay. Now see this one. Another question. Here, find the value of 1 watt on a system that has 100 gram, 100 cm and 1 minute as the base unit. In the systems of unit, we have not read this type of system. So it is a new system of unit. But this one we know what is in a SI system or MK system. Unit of what? Power. It is the unit of power. Okay. So we know that the power. Now we go for solution part. So now how we will solve this one thing? Simple, very simple. First write power. What is the dimension of power? Work by time. So work by time means how much? M1 L2 T minus 3. I think this is correct. M1 L2 T minus 3. Power equal to work by time. Work is M1 L1 T minus 2 by T1 time T minus 3. So here A, let me write here A1, B power of L 2, C power of T minus 3. That is given. We know that. Now we are converting from what system to SI system to new system. I will write, because this system is not named so far. It is a layman system. It is a, anybody has given this system, right? So let me take this size of the units, fundamental units in this system. But in SI I already know that M1, when I am measuring this watt, I know this M1 should be in kg, L1 should be in meter, and T1 should be in second. And N1 is given, that is 1. But in the new system, it is given that mass should be gram, 100 gram, base, and L2 should be 100 centimeter, and T2 should be 1 minute. I will not change this one, it should be 1 minute, right? And N2 should be, what this should be the N2. I will calculate. Use the same formula. N2 is equal to N1 M1 by M2 to the power A, L1 by L2 to the power B, T1 by T2 to the power C. This is my formula. So here N1 is equal to 1. What is M1? 1 kg divided by 100 gram. M2 to the power, what is A? 1. L1 is 1 meter. To the L2 is 100 centimeter. Put the values. Don't get any confusion. What I don't know, what we know the values, you put that. Okay. So it can be done by a standard 1 student. It can be done by a standard 1 student. Put the values. Already you know this one. And B is how much? 2. And second T1 1 second, and T2 is 1 minute. To the power C, that is minus 3. Clear? After getting this one, now you cancel, because you can make kg to gram or gram to kg. So it is easy to make this kg to gram for our convenience. Okay, so I can write 1000 gram divided by 100 gram to the power 1. 1 meter 100 centimeter divided by 100 centimeter. It's the double zeros. Okay. To the power 2, 1 second, 60 second, because I have to cancel this one, to the power minus 3. Because minute I can make this as a second. It is convenient for us. You can make this gram or kg or like that. It is up to you. So this gram, cm, second cancel. So what I will get here? This gives me 10 to the power 1. To cancel 10 to the power 1. This is 1. cm 100 cancel, 1 to the power 2. Then this gives me 1 by 60 to the power minus 3. Clear? 1 by 60 to the power minus 3. So now what I will get here? Now you multiply this thing. Okay? Now you have to multiply. So can we write this N2? Can we write this N2 is equal to 10 into 10 to the power 10, 1 to the 2 into 60 to the power 3. Right? So 60 to the power 3, I can write this as 216 000 into 10. 60 into 60 into 60. 60 into 60, 3600 into 60. Okay, 216000 I think. Okay. So now we will write like this. So we will get what? 216 into 10 to the power 4. That is my N2. So what I will write here? 1 watt is equal to 216 into 10 to the power 4 numerical part. In which system? You don't know whether it is CGS, MKS, FPS, you don't know. So simply write new system of unit. New system of unit. This is equal to this much in new system of unit. Okay? Clear? Is that clear? Okay. Now you see here again another twist of the questions to convert that on that basis. To convert the physical quantity from one system to another, I have done two, very simple. The next two are some twists are there, but it is very easy. Okay, isn't it? It is very easy. Then now we go for the solution. Right. So if the units of force, energy, and velocity are given, clear? Force is 20 Newton, energy 200 Joule, velocity is given. Find the units of length, mass, and time. Means here force, energy, velocity, I will consider these are the base units in a system. From that I will calculate the values or the units of length, mass, and time with its numerical value. How we will find out? Now you see here, first you write the dimension. Force is given, so force is 20 Newton given. So what is the force is? Force dimension is what? M1. So let me write here, force is equal to 20 Newton. Clear? That is given. Okay. So what we will write here? I can write this as force is M1, dimension L1 T minus 2. That is equal to 20 Newton. That is given. This much of is 20 Newton in the system. So this is a fundamental. Okay. Mass, length, time, already you know that. But remember, this mass, length, time is a new value we will calculate. Okay. But for this 20 Newton, to get this 20 Newton, 1 kg is 1 time, 1 meter is 1 time, 1 second is minus 2 times. Then we will get this 1 Newton, and it is how many times? It is 20 Newton. That is the meaning. Then energy is given. Energy is 200 Joule. So what is energy? M1, L2, T minus 2. Let me write this one. See how I am solving this one. Then you can do this type of questions anyway. Then time, that is given. Okay. And velocity. And velocity is 5. The velocity is how much given? It is 5 meter per second. Sorry. This is 5 meter. Let me write 5 meter per second. So I can write velocity as 5 meter per second. So velocity means L1 T minus 1, that is given me 5 meter per second. This is given. Now I find the units of length, mass, and time. Now give me equation numbers like this. This is 1, this is 2, this is 3. Now this is up to you. By using these three equations, you have to get what is M, what is L, what is how much is T. Now you divide this. Dividing equation 2 by 1, dividing equation 2 by 1. Let me divide this equation 2 by 1. Let me write 2 is what? M1 L2 T minus 2 divided by M1 L1 T minus 2 is equal to 200 divided by 20. 200 Joule divided by 20 Newton. So now this M1 get cancelled, T minus 2, T minus 2. L2 to the power, L to the power minus 1. So 2 minus 1. L1 is equal to how much? 20. Sorry, 10. This is equal to 10. Got it? So L1 is equal to 10. What is this value? This should be 10 meter because it is in meter. Because this is Joule. This is Newton. So this must be L1 is 10 meter. Clear? Now the next part. Then putting the value of L in this x3, putting L in equation 3. In equation 3. Put this L in equation 3. L1 is how much? 10 meter. So 10 meter, clear? Into t to the power minus 1 is equal to 5 meter per second. 5 meter per second. Clear? Remember this 1, 2, 3. Okay, now I am erasing. You remember this one, or otherwise you can write this. Then this is equal to, now what I will get here? 10 t minus 1 equal to 5, right? So t is equal to, so that means 10 t minus 1 means 10 by t is equal to 5. So t is equal to 10 by 5, that is equal to 2 second, because it is in second, that is equal to 2 second. Got it? Then put it from equation 1. From 1, after knowing this L and T, put that in equation 1. From equation 1, put the force equation. What is that equation? From equation 1, I will calculate this mass. M1, L1. L1 means what? 10 meter. 10 meter. Into t minus 2 into t minus 2, t is 2 second, it's minus 2, that should be equal to, how much this is value? 20 Newton. So by solving that we will get m into 10, this is 1 by 2 square, so 10 by 4 is equal to 20. So m is equal to, so you can make this as 10 to 8. This implies m is equal to 8, what? 8 kg. M is equal to 8 kg. This is the value. Okay. So, okay students, so far I have discussed some numericals examples based on the 3 applications of dimensional analysis. Now we will go to the last section, that is the what are the limitations of this dimensional analysis. Let me discuss the limitations. As already I have in the discussion of the numericals applications, I have already told you what are the limitations. Now let me again discuss the limitations. Okay. Now come to the limitations of this dimensional analysis. Means by this dimensional analysis what we are not able to find. As I have already given you that concept that it does not, it is, the method does not give any, it does not give any information about the dimensionless constant. It does not give any information regarding dimensionless constant K, dimensionless constant. We are not getting any information of the dimensionless constant, that is the K. Already I have given that K may be half, maybe minus half, or maybe pi. It does not give any information. Always we are taking that is a dimensionless constant. Number 2. Then it fails when a physical quantity depends on more than 3 physical quantities. It fails to derive. It fails when a physical quantity depends on more than 3 physical quantities, more than 3 physical quantities. Clear? Where we have discussed this? In the second application, go to the last video. In the second application, we have discussed this one. Because if there are 4 unknown, then you will get 3 equations and it is very difficult to get the value of 4th one. Okay? If A, B, C, D are given, that we are taking 3 equations, m to the power, l to the power, t to the power, and equating both sides. Clear? At that time I have told that. So I am not going in detail about these things again. Number 3. It fails when a physical quantity is the sum or difference of 2 more quantities. Right? It fails for a physical quantity. It fails when a physical quantity, it fails when a physical quantity, it fails a physical quantity is the sum or difference of 2 or more quantities. What is this one? As I have already told that. Why? Quantities. I have already told that. Suppose I will tell you, derive this is c is equal to ut plus half at square. Can you derive? If I will give you s, the displacement depends on, or distance depends on initial velocity, time and acceleration. You cannot get this one. Because the dimension of this one should be equal to this one, this equal to this one. It is not plus. Plus minus, that does not bother. Similarly, if it is also minus also, you cannot know. Right? So, this is the drawback. This is the third point. Okay? You are not able to derive this type of equations. These are called as the composite equations. Okay? Next we will go for the 4th one. It fails to derive a relations which involve trigonometric functions. It fails to derive a relation which involves what? Which involves the trigonometric clear, or logarithmic or exponential functions What it means? Exponential functions. What it means? Now you see here. Suppose I get an expression y is equal to displacement is y is equal to, I have a relation in physics, y is equal to r sine theta. What is the dimension of y? Distance. R is amplitude, that is also distance. We know. But what about sine theta? It is the ratio of length by length. When you take a right angle triangle, if this angle is theta, then sine theta, this, right, height by hypotenuse, this by this, sine theta. So what is its dimension? 0. So you can only get y is equal to r, the sine theta you cannot find. Similarly, if log is there, means in the relation which involves trigonometric, which has no dimension, logarithmic, which has log 10, has no dimension, or an exponential function, it has no dimension. So it is not able to find these values. Okay. So this is the next drawback. Okay. Next, if you don't know, very difficult. So it is difficult to identify. It is difficult to identify. It is difficult to identify the factors on which it is difficult to identify the factors on which a a physical quantity depends. A physical quantity depends. Physical quantity depends. Got it? What it means? When you derive the relation, when you derive a relation involving different physical quantities, then in the beginning I told you that you should know on what factors the physical quantity depends. If I want to find the dimension formula for force, then I should know that the force depends on mass and acceleration. If I don't know, then I am not able to find the dimension formula. So these are the main limitations of your dimensional analysis. So that means the dimensional analysis you can use the 3 applications and you can find, but with addition to that, these are the limitations. Okay. So my point is here that students, I have given you the videos and the videos are given to you. So this is your, I think that is your 4th video. From the beginning, my videos are long duration, 1 hour plus time. So you can watch the video. If you are not able to watch the video at a straight, for a long time, then you can pause that for 30 minutes, you can see, then close that, take some relaxation, then you go for the video. Okay, in that way you watch the video, and remember all the videos are interlinked, because in these limitations while discussing, I have already in the application part, there I have already told that these are the limitations. Recall that. So I have written it directly. Okay. So go through these videos, and in addition to that, do some extra problems. I have done only 2 to 3, because if I do more problems, then the duration will be 2 hours duration. Go through the video and do some extra problems or applications of dimensional analysis. I have done only the types, what the types of applications are there and how we will use that, and after knowing the path, now it is your duty to move along that path so that you can reach your goal. Okay, very good students. Thank you.